turn this off. Turn off that. Okay, so for 2.6, we're going to talk about rational functions. Now, rational functions are really just, they're just ratios. So for 2.6, when we talk about rational functions, ratios are what? What's a more common name for ratio? Huh? Okay, what's a common term for a ratio? It's a fraction, okay? So what we have is we're going to have f of x, and we can write f of x as a function over a function, so we can think of it like g of x over h of x. All right? And so there's some things, there's some properties, there's some things that we need to think about. For starters, what do we know about that? What do we know about h of x? H of x can never equal 0 because it's in the denominator, right? So h of x can never equal 0 because it's in the denominator. So that's one thing we always gotta think about. And so let's move on to the next slide, and we'll talk a little bit more about it. So what I'm going to do is I'm going to graph a function. So we're going to have actually let's do this. And so, I'm going to change the color a little bit here so we can see it. I'm going to say that f of x is equal to 1 over x minus 2. Now what did Mr. Adams just say about the denominator? Can't have a 0. Can you guys see the orange okay? Maybe I should do something like a blue or a purple.
Or white.
White? Hey, that's a good idea. Alright, so we said that x minus 2 cannot equal 0. Okay? Well, that's also how we set our domain up. In other words, x, if I solve for x, I get x cannot equal 2. Right? If I add 2 to both sides of that, it's not even an inequality, right? It's an anti-equality. All right, so then what we want to do is we want to look at this. We want to look at the end behavior. So the end behavior is what is the limit of f of x as x approaches infinity, and then what is the limit as x approaches negative infinity, okay? And so to give you guys kind of I'm going to do like kind of a rough sketch of what this looks like graphically, okay? It can equal 2, so if I get to 1, 2, I'm not going to have it's not going to cross there. So what it looks like graphically is I'm going to have a function that kind of goes like this. And I'll explain why it behaves this way in a second. Okay? And so what we're looking at is, what does this thing look like as x approaches positive infinity? Okay? As we approach positive infinity in the x direction, as we approach negative infinity. So look at the, and now I'll talk a little more informally. Look at the purple lines. What does it look like the curve approaches as x approaches infinity? In other words, as we follow the graph, this graph went on forever and ever and ever and ever and ever. What does it look like it approaches? 0. And there's a reason for that, and I'll explain that in a second. All right, now what if we look at this thing as it approaches negative infinity? So we want the limit of f of x as it approaches in this direction. What does it look like it approaches if I went on forever in that direction? 0. Okay. So now where does that come from? Does anybody know? Well, from the graph, duh, right? So if I plug in a bunch of x values and I graph all the points, this is kind of what it will look like, right? And we could study that behavior. So I guess what I want to do is let's figure that out. So if I say f of x is equal to 1 over x minus 2. First, let's talk about as x approaches infinity. Now, infinity means it's not a number, so it's going to approach. And really pay attention if you're thinking about taking calculus next year, because we do a lot of infinities things. Okay? We deal with infinitesimals a lot. So to wrap our minds around it this year will help you next year. Okay? Well, infinity in the positive direction is a really big number. It's a huge number. We're approaching very, very big numbers. So let's plug in a big number and see what we get. Somebody give me a big number.
3,400.
3,400. That's too small. Bigger. No, we don't. It's not a number. I can't plug in infinity.
A million.
A million? All right, we'll do a million. So now what we're going to do is we're going to say f of $1 million. Oh. You guys see that? So we got 1 over 1 million minus 2. A couple things I want to point out to you guys. When you minus 2 from a million, does that minus 2 mean a whole lot? Think in terms of infinity. What if we go to 10 million, 10 billion, 100 trillion? The bigger and bigger that x value gets, is that little minus 2 mean anything? No. What do you think this looks like on a calculator if you plug it into a calculator? Big. Hey, I want to show you something. I want you to think about it, right? Okay. So I've got this. Oh, I didn't want it right there, but that's okay. I've got this. Well, I was going to say pizza, but it's green, but that's okay. I've got a pie. I don't know why it would. That looks like peas, right? Like pea soup pie. But if I cut it in half, oops! I just want to cut it in half. There we go. If I cut it in half, oops, wrong one. Undo. Okay. If I cut it in half, I've got what? What do we call that as a fraction? 1/2 or 1 over 2, right? Right? Now if I cut it again, what do I have now? 1 over 4. Let me change the way that looks because you can't see it on this background. 1 over 4. If I cut those in halves, now what's that? 1 over 8. Now if I continue to cut this in half, and cut this in half, and cut this in half, eventually I'll reach something that looks like 1 over 999, 998, which is what that is. How big of a slice do you think I'm going to have? Very little slice, right? So does it make sense why as x approaches infinity, in this case it approaches 0? Because the more slices I take, or in other words, as my denominator increases, and the top doesn't change, it's got a constant number, which is 1, the bigger the bottom gets, the more we divide the slices, and the slices become smaller and smaller, which is why we approach 0. Now, if you say, well, we get the same type of behavior when we go towards negative infinity. Well, that's true. The only difference is, if I make this minus 1 million, what does this become? Whoops. Yeah, it's like negative 1,000,002, right? So it's like negative 1 million. Still very small slices in the negative direction. Does that make sense? Which is why when we look at the graph, we have negative, 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 and it'll stay negative and get really, really close to 0. But over here we have positive, 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 and it'll stay positive. So example number 1, just wanted to know what that looked like. Okay? That's pretty much it. And so does anybody know what the parent function of this function is? If you had to guess? This will be called the reciprocal function. And just like when we talk about transforming functions and moving things around and doing things, guess what this one does? Slides it left to right, adds it up and down, moves it up and down, changes it a little bit. But that's basically what it looks like. That's the parent function. We just tacked on a -2 on the bottom, which shifted it over a little bit. 2 points to the right.